Einstein's favorite Gedanken experiment is what is now called the Einstein's elevator. So let us go back to the void of space. Nothing is there at all, except one elevator, looks like a rocket ship, and the elevator is motionless. But now we'll do the following experiment. We will start accelerating the rocket, the elevator, and the observer looking through the window will see the floor coming up, coming into contact with the floating apple. And as far as the scientists know, all at once gravity has been restored. There is no experiment that anybody could do to distinguish between the acceleration of the elevator or the gravity you feel on Earth. That's really very interesting. Now, if we go back, and I'll take my apple, give it to one of the intrepid scientists, and the two scientists will play catch. The scientist on the left will throw the apple to the right, back and forth. But what you would see as an observer, as the apple went from left to right, it would appear to be curving downward. Well, you'd say that's not really true. It's only because the elevator has moved up. But Einstein says it doesn't make any difference. Now let's do another experiment. And this is a mind-blowing experiment. Let us shine the light beam, and if you had careful measurements, the light beam would follow the same path as the apple. It would be curved. And you would say, how could that be? And when Einstein first produced this paper in 1914, people were just unbelieving. Because is it possible that light will be affected by gravity? And of course, what Einstein said is that it's a time-space curvature. You can think of space as a fabric, and as a large body, meaning something like acceleration, it deforms that fabric, and we would interpret it as gravity. It's a wonderful, wonderful concept. But then people started to worry, well, how can you have space, which is nothing, and how can you curve nothing? Is there any experiment you could possibly do? Sir Arthur Eddington, he wasn't a sir at that point, decided that he would test Einstein's theory of curvature of space, space-time fabric. And so he devised the following experiment. If you take two stars, now if we look at these two stars, and of course tens of thousands of light years away, if we look at these two stars from Earth, they're fairly close to each other, and we know what the distance is, because we can measure the distance, we can measure the angle between them, therefore we know the distance between the two stars. Well, let's say now that we take our sun, and we take our sun and put it right smack in between these two different stars. What would you see? Well, you wouldn't see anything. Why? Because the sun is so bright. You don't see stars in the daytime. You only see it when the sun's not there. So how could you get rid of the sun light and not get rid of the sun? Aha! Eddington was very clever. In Africa, there was going to be the total eclipse of the sun. That's when the moon passes between the earth and the sun. Therefore, you have this black disk, and you have night. So he did the experiment and measured the distance between the two stars, the way I just told you, with and without a sun. And Einstein had calculated what degree difference would be because the light coming from the stars passing by the massive sun is bent, just like the light was bent in Einstein's elevator. And the number that Sir Arthur Eddington got was exactly the number that Einstein had calculated. Now I have two more stories. One story is they asked Einstein, what if Eddington didn't make that measurement? Maybe it didn't correspond to your equation. And Einstein, of course, said, I would have been very surprised. Just like Galileo would have been very surprised if the two balls hadn't hit the ground at the same time. And the last story, which is documented, there was a reporter who came to Eddington to write an article in the London Times about this wonderful experiment. And the reporter asked Eddington, he said, I understand that there are only 3 people in the world who understand Einstein's theory of relativity. And Eddington turned, he said, really? Who's the third? And the reporter's a little stunned, but of course Eddington said, he knew Einstein understood it, he knew that he understood it, and he was curious about the third. So ladies and gentlemen, that's my take on the wonderful new theory of Albert Einstein's gravity. And good night.